All right, so continuing on with 4.10, we had the very last problem there. And so we were working on example 5, and the bell rang, so I had to cut off the video. But so we were on 5b there, and it says, let's model this graph with a sine function in the form of y equals a sine of bx minus c plus d. Use your data plot to estimate the amplitude, period, vertical, and horizontal translations. Use these values in a sinusoidal equation and test your model by using your calculator to graph it on top of the data. All right, so I'm just going to do it on this piece here so that we can still see our data. All right, so we want to write our equation. It said in y equals a sine of bx minus c plus d. All right, so remember a, we find it by, it's our amplitude. And so our amplitude is your maximum minus your minimum divided by 2. So in this case, our maximum is 88.3 minus our minimum is 51.6, looking at our data, divided by 2, which gives me 18.35. B. Remember, to find b, we use the fact that our period is equal to 2 pi over b. So we're talking about the number of months in a year here, okay? And we know that we just said in the previous part there at the end of the other video that temperature is cyclic, that it's periodic, it repeats itself. So every January we expect the temperature to be approximately the same. Every August we expect it to be approximately the same. So that's every 12 months we expect it to be approximately the same. So our period is 12. So I'm going to set that equal to 2 pi over b, and I'm going to go ahead and just cross multiply and divide. So we get b is equal to 2 pi divided by 12, which reduces to pi over 6. Then I'm going to skip c right now. I'm going to go ahead and find d. D, remember, is that midline. And so it's always an equation, so it's y equals, and we find it using our maximum minus our amplitude. So in this case, our maximum was the 88.3 minus our amplitude you found was 18.35. And so we subtract them, and we find our midline is at 69.95. Now, what we have so far then is we have this piece of our equation. So we know y is equal to a is 18.35. It told us to use sine. We know that b is pi over 6. X, we don't know c, so I'm going to put minus c, plus we know d is 69.95. Now, doing this, we have 3 different variables still here. We have y, we have x, and we have c. So if I knew an x and a y value, I could plug it in and actually solve for c. Now, we can't do this one like we did back in 4.6 and 4.7 because the data is just really, it's not nice, perfect, and pretty, okay? So therefore, we can't just draw our midline across, which, where is 69.95 exactly? You know, so we can't just draw a midline across and try to figure out where C could be. Excuse me. But I do know that I have that ordered pair, and I could pick any of them. I'm just going to pick the first one, which is 1 and 51.6. Well, an ordered pair consists of an x and a y. So if I plug these into my equation, I should be able to solve for my C value. All right, so that I have room to do this, though, I am going to move up. I'm going to erase all this, so make sure you have it. If not, pause this video so that you can write it down. All right, so we said our equation was y equals 18.35 sine of pi over 6 x minus c plus 69.95. And we said we're going to use the ordered pair 1, 51.6 as our x and y to help us solve this. All right, so let me erase this now. All right, so let's plug that in then. So we got the 51.6 equals 18.35 sine of pi over 6 times x, which we said is 1, minus the c plus 69.95. Now notice c is inside the parentheses there with it's trapped with a sign, so we've got to get this sign part by itself. So let's subtract the 69.95 from both sides. And so we get negative 18.35 equals of 18.35 sine pi over 6 times 1. I'm going to go ahead and put as pi over 6 minus c. And that canceled. Now we're still trying to get the sine part by itself, so we're going to divide by the 18.35. So we get negative 1 equals sine of pi over 6 minus c. Now, we got a perfect negative 1 there only because it just worked out with our points, okay? But, excuse me, for our purposes right now, whatever you get when you subtract the d value to the other side should be really close to whatever your a value is, okay? So if it's off just a little bit, go ahead and just say that when you divide them, it gives you negative 1, okay? Give it the approximate there because we're able to use that negative 1 to help us solve. Okay, so now our problem is that my c is inside the parentheses here, so I need to get it out. But that's like f of x. We can't separate them unless we do an inverse. And so I can take the inverse of this, which would tell me then that pi over 6 minus c is equal to the inverse sine of negative 1. Because remember that inverse makes our input and our output switch. And so therefore now I'm taking the inverse side of that negative 1. It's equal to what was on the inside. So, oh wait a minute, let's see. Come over here to little work area / thought bubble. So we have the inverse sine of negative 1. Because it's an inverse, that means we're looking for an angle. Well, this is what we just did in 4.8 and 4.9. So this means I want to know sine of what angle would equal negative 1. Well, inverse sine tells me in quadrants 1 and 4. Sine tells me we're looking for the y value. So look in quadrants 1 and 4 and find where your y value is equal to negative 1. You'll find it's at 3 pi over 2. Problem is, remember that's the quadrant 4 area, so anything in quadrant 4 is too big because we know our answer can only be between negative pi over 2 and positive pi over 2. So subtract that 2 pi and you'll find it's at negative pi over 2. So we're going to take that answer now and we're going to plug it back in over here. So we've got pi over 6 minus c equals, and we just said inverse sine of negative 1 is equal to the negative pi over 2. So now to solve for c, we're just going to subtract the pi over 6. All right, so when I do that, I get negative c equals negative 2 pi over 3. Divide by negative 1. And we got c is equal to positive 2 pi over 3. Now that we know our c value, we can go back in and we can write our equation. And so I'm going to do that right underneath where I wrote the equation in red up at the top here. So let me erase some of this up here so I have some room. Alright, so our equation is now y equals, we got our a was 18.35, sine b was pi over 6x. Now, that minus c, our c was a positive 2 pi over 3, so we know in parentheses it's got to be a negative 2 pi over 3. And then plus 69.95. And so there is the equation that would give us the graph for those points.